So in this video, we will learn how to find the domain of a function. So let's say we have f of x, which is equal to x minus 3. So first of all, we need to understand what is the domain of a function. Simply, the domain of a function is all the possible values of x that we can put in this function without causing any issues. So for linear functions or quadratic functions such as x squared minus 6 or any function that is without any fractions or square roots or radicals, the domain is from negative infinity all the way to positive infinity. Now the real issue starts when you have fractions or let's say radicals or logarithm functions. So let's start with those examples now. And to show this on the line graph, it will be from positive infinity to negative infinity. So negative infinity is on the left hand side, positive infinity is on the right hand side, and this is to indicate that it's from negative infinity to positive. Now let's say we have another function f of x is equal to 1 over x minus 3. So now whenever we have a fraction and the denominator is 0, this is undefined. So we cannot have this 1 over 0. We cannot have a 0 in the denominator. So here what we need to do here is to equate the denominator to 0. So x minus 3 is not equal to 0. So x cannot be equal to 3. And how do we write this now in the interval notation? So it is from negative infinity to 3, not including 3. And let me show you the difference between the two brackets. So there are two brackets. This is the closed bracket and this is the open bracket. Closed bracket meaning that we are including the value of 3, and open brackets mean that we do not include the value. So it goes as close as like 2.999 and so on, but it can never be 3. So this is why we use the open brackets here. Now we do union from 3 all the way to positive infinity. And for infinities, we only use this open brackets. Just keep that in mind. Let's do another example. F of x is equal to 9x plus 1 over x squared minus 9x plus 20. So again, the same step, we need to equate the denominator to 0. So x squared minus 9x plus 20 cannot be equal to 0. So let's equate it to 0 and factor this now. So what two numbers multiply to 20 and when added gives you minus 9. So we can write all the factors for 20 here. It will be 1 and 20, and then 2 and 10, 3 is not there, 4 and 5. And we notice that minus 4 minus 5 gives you minus 9, and minus 4 multiplied by minus 5 also gives you 20. So these are the two factors. So x minus 4 and x minus 5. So x here cannot be equal to 4, or x cannot be equal to 5 here also. So now let's write the domain. Let me just erase everything. So starting from negative infinity, you go all the way to 4 first, and then close brackets, we're not including 4, union from 4 to 5, union, and then from 5 all the way to positive infinity, and that's the answer. And to show this on the line graph, let's draw a line. There's a 4 here and there's a 5, and now there is a difference between an empty circle and a filled circle. So empty circle meaning that we are not including the number which is on the line, and filled circle meaning that we are including the value. So here we need to use the empty circle, so that's why it's from we put an empty circle on 4 and 5 here to indicate that we are not including 4 and 5. So here now you draw a line. Let me change the color. There is empty circle here for 5 and then all the way here, and that's the line graph for this problem. You can also write 4 and 5 here. So here let's do a tricky question. So try to pause the video and try to do this yourself. So again, the first step is to equate the denominator to 0 here. So x squared plus 4 is not equal to 0. We take 4 to the other side, so x squared is not equal to 4, negative 4, sorry. Now, do you notice something? There is a x squared here, and we are equating it to negative 4. And we know that x squared, anything, like any value squared, is always a positive number. So it can never be a negative number if you square any number at all. So you can try any value, negative 1, negative 2 in your x, and you will always get a positive number, since any number squared is always going to give you a positive number. So here in our example here, this x here is never going to be negative here, or I mean to say, yeah, negative here. So here the domain will be from negative infinity all the way to positive infinity, and that is the answer. So here we're going to move on to radicals now. So here we have f of x is equal to radical of x minus 3. So now the basic rule for radicals is that the inner part of the radical is always has to be more than or equal to 0. So you just equate it to whatever the inside of the radical is, x minus 3 is more than or equal to 0. So now you bring 3 to the other side, so it will become x is more than or equal to 3, and that is your domain. So now how do we write this on the line graph? So let's draw a line graph, positive infinity and negative infinity, and we have the, let me change my color. So we have a 3 here. So here it's going to be the shaded circle because we are including 3 here, and all the way to positive infinity. And if you want to write it in the interval notation, it will be 3, and you notice that I use the close bracket this time because we are including 3 this time, all the way to positive infinity, and that is the answer. So let's do another example. F of x is equal to radical of square root, x squared plus 3x minus 28. So now whenever you have a quadratic equation in the radical, first step is to again factor this. So what two numbers multiply to negative 28 and add up to 3, so it will be negative 7 or 7 and 4, actually 7, positive 7 and negative 4. Since 7 minus 4 is 3, and 7 multiplied by negative 4 is negative 28. So let me write it in that format now. X minus 4 is more than or equal to 0 this time. So now we know that x can be negative 7 and x here can be 4 since 0 is included, right? So let's draw the line graph. There is a negative 4 here, or sorry, negative 7, and there is a 4 here. So now these two are included. Let me change my color. So now to find out if these regions to the right and in the middle of the numbers or to the right of 4 is included, we basically just try any value between these regions in the equation here and see if it's more than or equal to 0. So any number which here is more than 4, let's try 5 here. So let's 5 and put it in this equation. So it will be 5 plus 7, which is positive, and 5 minus 4 is also positive, it's 1. So positive times positive is always going to give you a positive number. So this region is positive. Now let's try a number between negative 7 and 4. So let's try 0 this time. So 0 plus 7 is positive and 0 minus 4 is negative. So now a positive number multiplied by a negative number is negative. So this region is going to be negative. And now let's try the region to the left of negative 7. So negative 8, let's say. Now if we put negative 8 here, negative 8 plus 7 is negative, and negative 8 minus 4 is also negative. Now you know that negative number multiplied by another negative number is a positive number. So this region is also positive. And as we discussed before, we cannot have a negative inside the square root here. So the region between negative 7 and 4 is not included. And the only region which is included here are these two regions, including negative 7 and 4. So now let's write the interval notation here. So it's going to be from negative infinity to negative 7, and don't forget the brackets to use close brackets, union, open brackets, the close one, 4 to positive infinity. And that's it, that's the answer. So now what if you have a fraction and you have a radical in the denominator? So let's try an example. F of x is equal to 3x minus 1 over radical x plus 2. So we cannot have a 0 in the denominator and we cannot have a negative value in the radical. So these two conditions are there. So x plus 2 has to be more than or equal to 0, and for the fraction denominator rule we cannot have a 0. So here we need to remove the equal to, and that's it. So x has to be more than or equal to negative 2. Oops. And that's it. So the answer would be, and to write this in the domain format, so it will be not including negative 2. So that's why I use the open brackets, negative 2 all the way to positive infinity, and that's it. So in our next question we have a radical in the numerator, so x minus 3, and in the denominator we have a perfect square, so x squared minus 25. So how do you think we should start this? Now for the radical numerator part we can just set it more than or equal to 0. So let's do that right now. X is more than or equal to 3, so we know this. And for the denominator here we can factor this, so it will become x squared minus 25 is not equal to 0, and we can apply the difference of perfect square here, so it will be x minus 5 and x plus 5 is not equal to 0, and here x cannot be equal to 0, x cannot be equal to 5, and here x cannot be equal to negative 5. So now let's draw a line graph to visualize this better. So we have negative infinity here and positive infinity. We know that it has to be more than 3, and we have a negative 5 right here and a positive 5. So now let me change my color. So we know already that it has to be more than or equal to 3, and it cannot be 5, so we need a empty box over here. And for negative 5, as we already are only including the domain more than or equal to 3, we don't need to look at this anyways. And this is it then. So it has to be 3 or more, and it cannot be 5. So how do we write this down now? So it will be domain from including 3 to 5 and not including 5. So close brackets, open brackets, and then union not including 5 all the way to positive infinity, close brackets, and that's it. So our last question is a bit challenging, so I would need all your attention. So f of x is equal to radical of x plus 3 over radical of x squared minus 16. So we have two radicals in the numerator and in the denominator here. So let's do the numerator first. So x plus 3 is more than or equal to 0, and x has to be more than or equal to negative 3. So we can draw a quick number line here and indicate this. So negative 3 and positive, we are including this all the way to positive infinity. Now for the denominator, let's quickly factor this, and this has to be, so the two rules are that denominator cannot be 0, and for the square root it has to be more than or equal to 0, right? So to satisfy both of the conditions, we can just remove the equal to sign, and now we can factor this. So it will become x plus 4 into x minus 4. The difference of perfect square is more than 0. Now x cannot be equal to negative 4, and x cannot be equal to 4. This is a very similar example what we did before. So let's draw the number line again. Negative 4 and 4. And now we need to test for the regions more than 4, between negative 4 and 4, and less than negative 4. So here let's take a number more than 4. Let's take 5 and replace it over here. So 5 plus 4 is a positive number, and 5 minus 4 is 1, so it's a positive number. So a positive number multiplied by another positive number is always positive and more than 0. So we know that this region is positive. Now let's choose a number between negative 4 and 4. Let's choose 0, very easy example. So 0 plus 4 is a positive number, and 0 minus 4 is a negative number, and a positive number multiplied by a negative number is negative. So we know that the region here is negative. Now for less than negative 4, let's take negative 5. So negative 5 plus 4 is negative, and negative 5 minus 4 is also negative, since it's going to be negative 9. And two negative numbers multiplied will give you a positive number. So this region is positive. So now how do we proceed this? Because we have two number lines and we need to merge them now. So to merge them, let's create another number line including all the intersections and etc. Oops. So we have negative 4, we have negative 3, and we have 4. So the first thing is that it has to be more than negative 3 and including negative 3. So this will be the first thing. And we also know that the region between negative 4, one more thing I forgot to mention is that the region before negative 4 is positive, but since this is not satisfying the upper number line, we are going to ignore it. So now we also know that the region between negative 4 and 4 over here, let me actually make more space here. So as I was mentioning, first of all, it has to be more than negative 3 and including 3, and we can completely ignore the part before negative 4 since it's not satisfying this part over here. And we also know that the region between negative 4 and 4 is negative, so we automatically know that all this part over here is not going to be included, and the only part which is going to be included is more than 4, since that is the only intersection between the two number lines. and 4 is not included, by the way, so empty circle over here, and that's the answer. So now to write the domain, it will be domain from not including 4 all the way to positive infinity. So as always, I do have a shortcut method to recheck your answer for this question. So after you get the domain, let's go back to the original equation and substitute any values between this number, in between this domain and before this. So if you substitute 3, you will get undefined answer. So you know that you are on the right track. And now let's just like substitute 4. 4 is also going to make this undefined, since this here is going to be 0. Now if you substitute any value more than 4, let's say 4.1 or 5, you will get a number, or you will get an answer for your calculator. So you know that it is included. And let's say you substitute 0 and it's not in the domain, so it's supposed to give you error, or it will give you undefined answer. So that's a way to recheck. And you can, last try you can do is like 9999 or something like that, and it should give you an answer. So that's it for that video. I will make a short video on how to do that on the calculator, since it will be more easier to show you guys. And thanks for watching.